Hello guys, in this episode I want to explain discontinuous blocks, which are a bit complex and are a little difficult to work with them. I try to start from the simplest block. Here I begin with saturation. I add it to my new model. If you remember, we had saturation in integrator in the continuous blocks library, which was used to limit the integrator output, but we can add saturation to any other block without integrator. I double click on the block. As you can see, I can set the upper and lower limit, which its default is 0.5 and minus 0.5. I want to work on the model in order to get know about its applications on simulations. I should use a source input. I create it by signal generator. I add a mux and a scope. I will explain signal generators completely later. Here I want to use the signal generator to create a sinus wave. Connect it here. And I connect this part, and this one to here. Okay. I set the amplitude 1 and the frequency 0.25. Here we accept the saturation block default values. The first input was a sinus wave. The mux block second input was saturation output. As you see, it is limited between 0.5 and minus 0.5. This signal is the result of saturation block. In fact, we had a limiter on output signal. We have another block related to saturation that its name is saturation dynamic. In this block, you should set the lower and upper limits values manually. For example, suppose that I want to have the above model, but in this case I want to set the limits manually. For this case I use two constant blocks. The saturation block first input is upper limit and the second input is for lower limit, and the middle block is for signal which I want to use it in saturation. I use the signal that I used in previous model. I don't change the signal generator values to compare these signals. I set it here. I use mux. Like this, I connect it to this part. And this one to here. Okay, now as you can see, there's a sinus half wave from 0 to P. Okay, it was another application of saturation dynamic in which you define upper limit and lower limit by signal manually. As I said, Simulink created these dynamic blocks so you can define the upper and lower limits as a variable. I save this model as saturation. Here there's an error. Save it. But it may cause some problems for you in the future in the way that your files in Simulink and MATLAB mixed up and get false output in Simulink. So I just suggest to change the name of your file if its name is same as a file name in MATLAB. Okay, the next block I want to explain is dead zone. Here we have the start of dead zone and the end of dead zone. When the input function set between these two zones, the output will be 0. If the function was higher than end, the input will be subtracted with this amount and gives us in the output. Also the processing mean start dead zone. Now I explain this block with one example. I do the same work on this block like the previous simulation. I consider the signal generator as a sinus wave. I want to do that. Set it here. Now this one here, and I connect them to each other. This one to this part, and this one. Okay. I consider a signal generator as sinus wave and set its amplitude 1 and its frequency 0.2 Hertz, and also set it a start of dead zone and end of dead zone minus 0.25 and plus 0.225. And as I said before, if the output be between minus 0.25 and plus 0.25, the given output is 0. It means that if the output be between the two amounts, the output will be 0. This is our input signal without dead zone. At this moment, that is between the 0 and 0.25, our signal gets 0 because, as I defined in the block, when the input is between the minus 0.25 and 0.25, our input gets 0. After that, when the input passes through 0.25, our main signal will be minus from 0.25. It means that our output signal isn't this signal, and it is the main signal minus 0.25. And then when reached to 0.25 again, our signal gets 0, and after that our main signal will be minus from 0.25. This process continues up to end of simulation. This block is a useful block in simulation because you can set your input in a specific zone. Here we have dead zone dynamic. It's same as dead zone, but as upper and lower limit. I double click on the block, but as you can see, I cannot enter any amount as input. I should enter the amount from here. As I said here, the difference of this block with dead zone is that you can enter upper and lower limit dynamically or varies with time. As we can see, the output is limited between minus 1.5 and to 1. I save this model as dead zone limit. Here the error is because we used space on file name. Actually, Simulink is sensitive on the saving. The other block is rate limiter. I click on the block and here you can see its detail. As you can see, the rate of signal is limited by rising and falling options. I mean that the block limited the first derivative more. Let's simulate a model. Here I use step. I will explain this block in detail later. Connect it here. I put it on default mode. Here we have an error. As you can see, it says that our input signals to rate limiter are neither discrete or continuous. So in order to solve it, we should change the sample time of model. Because if the sample time be 0, the system won't be discrete and cannot run it in the continuous mode. The answers, as you can see, are consistent. You can have different outputs by changing this amount. We have rate limiter dynamic too. Here I change the system a bit in order to show the application of block. I use sinus wave or signal generator and constant, just as previous projects. Here we should give two inputs to the system. The middle signal is the main signal. I enter the two limits as constant. I set the upper limit 1 and the lower limit -1. I set the signal generator amplitude to and its frequency 2 Hz. Here I connect it to this part. This one here. Again. Now run the system. We have an error which is related to the existing sample time of Simulink. Pay attention that there are lots of errors in Simulink. So you may face some errors in your simulations. But these types of errors are related to sample time of these blocks. They use these amounts in the default mode. I replaced the signal generator with the sinus wave block, and here I set its amplitude to, and its frequency 2 Hz, and the phase amount pi divided 2. Again, we have the error. In order to solve it, I go to simulation and choose the model configuration parameter. I will explain this part in the last chapter. That's how simulations are done and how you can change different methods of integration. In the solver option part, I change its type from variable to fixed. I can choose integration methods which are related to fixed mode, and also I can set the step size that's used in the fixed mode. As you can see, the error has been solved, but the simulation accuracy decreased a lot. The reason is that the Simulink has applied big and fixed steps. We can modify it and have accurate simulations by defining smaller steps. Here, I ignore it. I save this model as rate limit. Okay. Then be back to this library. The next block is relay. It's same as what you see in Dustery and houses. It's like thermostat relay of air conditioning, which turns on and off in specific times. I double click on the block. Here we can see the switch on point, which means at what time the system turns off or on. Also, we can define what output it gives us. For example, when it is on, the output is 1. But when it is off, the output will be 0. Okay, here I work on a simple example using constant and relay, constant display. Here I set them here like this. Okay, and this one here connected to this part, and this one to here. Here I set the amounts. Now if I run the simulation, you can see that it shows 1, which is because of on point activation. As you saw, the relay with different types of inputs is working between 0 and 1, or connect and disconnect. It's similar to relays that you can see normally. Another example in Simulink and delay is about a heating system. I recall it to see the example. You can use this example in your projects if you work in this field. All of MATLAB examples are saved with special names. You can use SLDemo to call them and then use the file name. The title of this example is house heat. I type it with underline after SLDMO the example that was called is a thermal model of a house. Also here, time given in units of hours, the part which is related to relay is available in the thermostat of that house. You can see here that I use the relay for thermostat. As I said, thermostat relay has industrial usages. Okay, I close the block which is related to relay, but I do not save it because it's very simple. The next block is a quantizer. This block transfers the input from the stair step and show the output. I double click on the block. Here we can see the quantization interval. It means that the width of stair is 0.5. Here I want to have simulation with using this block. I add some signal generator and scope block. I connect it here and this one here. In the signal generator, I set the wave for parameter scene and set its frequency 0.25 Hz. In the quantizer block, I set the quantization interval 0.25 and then run the Simulink. As you can see here, we have the sinus signal, which is a stairs form. The size of stairs is 0.25, and we have this form in all of the simulation time. I save it as quantizer limit. Back to discontinuous block. The next block is heat crossing, which has interesting applications. It recognizes the input which is passing from it and enter a heat in the set time. Okay. Here in the heat crossing offset, we set an amount, and when the input reaches that amount, it will be recognized and show it in the output with the impulse. We usually use it in recognition. We want to show the application of this block with a simple example. I add marks, signal generator, and scope blocks to our model, and in the heat crossing block, I set the heat crossing offset value here. First, I connect them to each other. Heat crossing block, I set it crossing offset value -1, and in the signal generator, I set the frequency value 0.25 Hz. I run the model. Here we face with an error. The reason is because that the data types are mismatched. It means that dates which are implementing in simulation are not matched. This error says that the MUX block second port expect a signal of data type double. However, it is driven by a signal of data type Boolean. As you know, there is a block in commonly used blocks that its name is data type conversion, which can convert these data. I use this block and set it on the output of heat crossing block. the Boolean signal enter, the data type conversion, and then the double signal exit from it. So in this block, I set the output data type as double and then run the system. Now, as you can see, we don't have any error in data type conversion could convert the Boolean signal to double. But it was one of the application of data type conversion that I showed it here. As you see, the output here, the scope first input was a sinus wave that you can see it here, and its second input was the heat crossing block output that we set it in -1. That way, when it reaches to -1, the scope shows an impulse. I try to explain the most useful blocks here. The other ones which I have not explained are not applicative as much as those which have been explained.